Hello everybody. In this session, I'll discuss the Pauli's exclusion principle. Okay. So the four quantum numbers n, l, ml, and ms, that is principal quantum number, orbital quantum number, magnetic orbital quantum number, and magnetic spin quantum number, determines the state of an electron completely. State of an electron completely means how the electrons are distributed in different subshells and thereby different main shells. Okay. So thus the Pauli formulated a principle known as Pauli's exclusion principle. According to the principle, it states that no two electrons in an isolated atom can have the same four quantum numbers. Okay, no two electrons in an isolated atom can have all the four quantum numbers same. This principle implies that electron in an atom must have different set of these four quantum numbers. So not only we can select these four quantum numbers n, l, ml, and ms, even you can select n, j, mj, and ms. Okay, let me repeat once again. Not only these four quantum numbers have to be taken to give the explanation of the distribution of electrons, even you can have a combination of the quantum numbers n, j, mj, and ms. But the thing is that process of calculating j will be little bit lengthy compared to the calculation of ml and l here. Okay, thereby this is the simplest way of combination of the four quantum numbers here. Okay, so if two electrons have all their quantum numbers identical, that means if the two electrons have all the four quantum numbers same, then one of the electron would be excluded from entering into the constitution of the atom. Thereby, this principle has got the name exclusion principle. Okay. So this principle enables us to calculate the number of electrons that can occupy in the given subshell. Now, I will take one or two examples here. Consider the first orbit, that is k orbit with n is equal to 1 value. I have made a tabular column here just to understand quickly how to assign the values for each of these quantum numbers n, l, ml, and ms. I have to take n is equal to 1. If n is equal to 1, l can take only the one value, that is 0. For each value of l, ml can take the values from minus l to plus l including 0. If l is 0, automatically ml will be 0. ms will be always having two values. One is plus half, the other one is minus half. So 1, that is n is equal to 1, l is equal to 0, ml is equal to 0, ms is equal to plus half. These set of four values constitutes one electron. Similarly, so these three may be same, but this value is different. Thereby, this can be considered as the second electron in the first orbit. Did you got this one? So though the three values are same here, but the fourth value will be different from each other. Thereby, the first orbit can have two electrons here. So the first orbit will be completed with two electrons. So the subshell, we call it as a S subshell, that is L is equal to 0 corresponds to S subshell. Now we will take one more example so that we can clearly understand. So consider the second main orbit, that is L shell, and for L shell we know that the value of n is 2 here. Okay, list out the things n, l, ml, and ms for all these values. Okay, for n is equal to 2, l can have two values, 0 and 1. When n is equal to 1, l can have two values, 0 and 1. When l is 0, ml is having only the one value, that is 0. But when l is 1, ml can have three values, that is plus l, 0 and minus 1. And ms, for each of these values I have written together. In the previous case I have shown it separately. Now I will show you once again. In this case I have shown it separately, plus half 1 electron, minus half 1 electron. Now in the next one I have listed together, so that these are two separate values, and therefore I have given 2 here directly. Okay, so ms each are having a two values here. So the L is equal to 0 corresponds to S subshell, is completed with 2 electrons. Similarly, L is equal to 1. For all these, it is corresponding to P subshell, and in each of these we have a 2 electrons. Therefore, the P subshell can be accommodated with 8 electrons. Thereby, the L main shell, the second orbit, is accommodated with the 8 number of electrons, that is 6 of p electrons and 2 of s electrons. The sum of these two will give you the 8 electrons. So one more example I have listed. Quickly you can go through this one. That is the third orbit I have taken into account, that is n is equal to 3. So if n is equal to 3, L can have 3 values, 0, 1 and 2. Okay, and for each of these ML can have, for 1 it is -1, +1 and 0. For 2, for L value 2, ML can take values -2, -1, 0, +1 and +2. And each of these assign MS to 2 values, thereby we will get 2 in the S orbit, 6 in the P orbit, and for D's orbit we will get, or the D subshell will get the 10 electrons, 2, 4, 6, 8, 10. Therefore, the third orbit can be accommodated with the total number of values as 18. Okay, 10 plus 6 plus 2 is 18 electrons can be accommodated in the third electron. So like this, Pauli exclusion principle will help us to distribute the electrons in main shells as well as in subshells. If you have the total number of subshell electrons, that will give the number of electrons in each of the main shells. Thereby we can come to the two conclusions from this principle, that is, in nth subshell, that means nth nth shell means each main shell, there are n subshells corresponding to the values 0, 1, 2, etc. to n minus 1 of L values. Okay, the maximum number of electrons in the each subshell is given by the formula 2 into 2n plus 1. So I have listed the values according to this formula. Now you see 0, if you substitute 0 here, we will get 2. So according to the formula, the maximum number of electrons that can be accommodated in each subshell is given by the formula 2 into 2L plus 1. So the value is according to this. When L is 0, we get 2. When L is equal to 1, you can substitute and check it out, you will get 6. Like this, I have listed few values here, and the corresponding subshell values also I have designated in this last column. Okay, so this is the first conclusion made by the Pauli. Okay, the another conclusion made by the Pauli's exclusion principle is the maximum number of electrons. I have denoted the letter X for it, just for the calculation purpose I have taken like this. The maximum number of electrons that can be accommodated in each main shell with the principal quantum number n is given by the algebraic sum of the electrons which are present in the subshells. So that I have written it as sum of the electrons in the constituent n subshells. Okay, so that is nothing but an algebraic sum. L is from 0 to n minus 1. I have listed the values of L values here. L can take the values from 0 to n minus 1. Same thing I have taken as a limit here. So of 2 into 2 plus 1, because this will give you the maximum number of electrons in the subshells. Okay, so 2 we have to take out of the summation here. So the sum can be written like this. So you just go on, put the values, the limits of this into, that is L is equal to 0, 1, 2, 3, etc. We will get the sum as like this. Okay, for a lower limit as well as for the upper limit, it will be in this fashion. So this sum is known as arithmetic progression, whose sum is given by the formula n into a plus L by 2, where a is the first term and L is the last term of the progression. Okay, substituting the value of a and L, will get, then 2 is retained as it is and n also is retained as it is. The first term in the progression is 1 and the last term in the progression is this. Okay, just open the bracket here. Okay, so 1 plus 1 becomes 2. Okay, 2n minus 2. Multiply this 2 in the, open the bracket, 2 into n is 2n. 2 into 1 with the minus sign, written minus 2. This 2 gets cancelled, 2n by 2, and again this 2 gets cancelled, simply n within the bracket here. So overall it becomes a 2n square. Okay, so these are the two conclusions made by the Pauli, and this will give you the maximum number of electrons that can be accommodated in each main orbit. So each main orbit can be accommodated with the rule 2n square law. Okay, 2n square rule it is. And the subshell, each subshell can have the maximum number of electrons is given by the formula 2 into 2n plus 1. So this is all about the Pauli's exclusion principle.